So on this video, we are going to go over how to approach the homework on organic assignment number 1. Now, in order to eventually get to nomenclature of organic compounds, we have to first be able to identify what kind of organic compound we're looking at. And so I gave you this chart. You can have this in front of you. I strongly recommend you have this in front of you as you're doing the homework. It's going to make it so much easier. Before we can name the chemicals, we have to first identify what kind of chemical it is. Now we know that they're all organic because they have carbon in them, but there are different types of organic compounds. There's alkanes, alkenes, alkynes, alcohols. You can see all of those listed on the chart. So for this assignment, what we're going to be doing is we're going to be looking at these two columns right there. Okay? Have this in front of you and be looking at this right in here in order to help you. Now, if we start off with our functional groups, an alkane, A-L-K-A-N-E, it's not on the chart, but an alkane is a compound that's made up of carbon and hydrogen only, and it has single bonds. An alkene, and you'll notice it is an E-N-E ending, it has double bonds. And so if you look at a chemical and it has the double bonds, then it's going to be an alkene. An alkyne has triple bonds between the carbons. An alcohol, now an alcohol, I don't really like the way they've drawn that out, but it's a carbon that's attached to an OH. Okay, let's see if we can show you a little different one of that. So here I just inserted another chart, and so you can see on our alcohol it's a carbon attached to an OH. This can be anywhere within the chemical compound. The OH can come off of the end carbon, it can come off of a carbon in between, but any carbon that has an OH attached to it is an alcohol. An ether is a chemical where we have a carbon and we have a chain of carbons this way. It can be 100 carbons, it can be 1 carbon. And then we have an oxygen and we have another set of carbons. So it's basically a chain of carbons, an oxygen, a chain of carbons. A Hallow Alkane, now this is where we have not an X, but a halogen attached to a carbon. And that's going to be like a bromine, an iodine, a chlorine, but any of those would be a halocarbon. An amine has a nitrogen attached to a carbon, and here we can see it's got that nitrogen attached. The nitrogen needs to be to have 3 bonds, so that's why we have those hydrogens right in there. An aldehyde. Now an aldehyde is at the end of the carbon chain. You'll notice it's right here. It's at the end of the chain. It's a carbon attached to an oxygen. It's double bonded, and then it's attached to a hydrogen. A ketone is where we have this carbon chain. Here, I like this right here. And then somewhere in the carbon chain you have a double bonded oxygen. A carboxylic acid is where we have carbon double bonded to an oxygen. That carbon is also attached to an oxygen and a hydrogen. Now, we've got that right here. And we typically will see that at the end of the chain. So our carboxylic acid and our aldehyde will only be at the end of carbon chains. An ester, when we look at an ester, what we have is, you'll notice right over here, we've got the carbon double bonded to an oxygen, it's attached to another oxygen, and then you have your chain. So this is the only one where we have carbon double bonded to an oxygen, attached to another oxygen, and then the oxygen is attached to more carbons. And then finally, the amide, you have carbon bonded to double bonded to an oxygen, and then it's attached to a nitrogen. So let's see how we can use this on our upcoming homework. So your answer choices on this page are listed right up in here. Okay, and we're going to go through this page and help you with this page and then let you do the others. Alright, so you have that chart out in front of you that's going to help you. And then as we look at this chemical right here, you'll notice that we have this chain of carbons, but at the end we have a carbon double bonded to an oxygen attached to a hydrogen. Now look at your chart, see if you can figure out what that would be. You can pause the video, look, see if you can figure it out, and then we'll see if you did the right answer. Okay, so hopefully what you can see here is that this is an aldehyde. An aldehyde, you have that carbon double bonded to the oxygen attached to the hydrogen. Now, as we look at this one right here, you only have two on the chart that have nitrogens attached to it. That's the amine and the amide. And as you look at those two, you'll notice the amide has the carbon attached to a nitrogen, but the carbon is also attached to an oxygen. So we know it cannot be an amide. If we look, we have just carbon attached to a nitrogen, and it's got the hydrogens. This would be an amine. Now this right here, this is one way to draw out a chemical compound where each of these corners represents a carbon. And so if we were to draw it out, it would be carbon, 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 like this right here. And then you see those lines, those represent rotating double single bonds. And so we have it looking like that. But to make it clearer and easier for us to follow, we draw it out that way. Now, anytime we have a 6-carbon compound and we have rotating double single bonds, this is known as an aromatic compound. Now, this one right here is different from this one. Now, yes, this is circular, but you'll notice you don't have those rotating double single bonds. Also, when we look at this one right here, let's see, yeah, that's the main thing, because we've got 6 carbons there. Alright, because we don't have the rotating double single bonds, this would be a cyclo compound. So it's aromatic if it's a 6-carbon compound like this right here. It's got rotating double single bonds. If it's just a circular compound, it doesn't have the rotating double single bonds. It's a cyclo compound. Now, if we look at number 4, you'll notice that we don't have anything on it except carbons and hydrogens. Okay, so then we look at it and we'll notice that right there it's got a double bond. And so if you look at your chart, the ones that have double bonds are called alkenes. A-L-K-E-N-E. This one right here, we look at it, and it's got that OH there. So a carbon attached to an OH is an alcohol. Now let's look at the difference between this one and this one. This carbon is attached to an oxygen and a hydrogen, but notice the oxygen and hydrogen are not attached together. So it's carbon double bonded to the oxygen, and then the carbon's attached to the hydrogen. This right here is an aldehyde. It can only be at the end of the chemical compound, where this right here is an alcohol. The carbon is attached to the oxygen and the hydrogen, and an oxygen-hydrogen like this right here can be at the end, or it can be at the middle, or anywhere along the chemical compound. Now, as we look at this one right here, when we look at this one, you'll notice that we have a carbon chain, and we've got it separated. This is separated from this one by an oxygen. And so when we have a chain separated from another chain by an oxygen, this is an ether. E-T-H-E-R. As we continue, we look at this one right up in here, and you'll notice that we have a chain right there, and then on this chain we have this double bonded oxygen right there. Now, if you look at your chart, this right here is a ketone because we have a chain, and somewhere on the chain we have a double bonded oxygen. If we look at this one right here, you'll notice we have a carbon double bonded to an oxygen. That carbon is attached to an OH. So this right here is what a carboxylic acid looks like. This one right here, we look at it, you'll notice as we're looking to see what's going on, we have a carbon attached, it's double bonded to an oxygen. The carbon is also attached to a nitrogen. If we go back and we look at our chart, you'll notice the only one that fits that criteria is the amide, A-M-I-D-E. And that's because the carbon is double bonded to an oxygen, it's also attached to a nitrogen. Now, notice the difference between this one and this one. The carbon is double bonded to an oxygen, but instead of being attached to a nitrogen, it's attached to an oxygen. So you've got carbon double bonded to an oxygen, attached to another oxygen, and then there's a chain or more carbons following. So this right here is an ester. On this one right here, if you look at it, you got your chain, and then coming off that center, you have an OH. So that would be an alcohol. Right here, looking at this one, you got that triple bond there. Go back and look at your chart, and with that triple bond, you would have an alkene. An alkyne, spelled A-L-K-Y-N-E. Okay, now looking at this one right here, you got a carbon chain going across here. You got carbons there, so all we have is carbon and hydrogen. We don't see any double bonds. We don't see any triple bonds. So this is an alkane, A-L-K-A-N-E. This one right here, looking at it, you'll notice the nitrogen stands out. The carbon is not attached to an oxygen. The only choices I have is an amine or an amide. Because there's no oxygen attached to the carbon, this is called an amine. Alright, so I've done the first ones for you. I'm leaving the last parts for you to do on your own. This should be able to help you along.